What if I told you that a black hole, an object famous for swallowing light, crushing stars, and bending space itself, has made a sound? Not in a sci-fi movie, not in an animation. A real sound captured from a real black hole 250 million light years away. And when scientists released it, the internet called it the sound of doom. But here's the twist. Black holes don't actually make sound the way you think they do. Space is almost completely silent. So what exactly did NASA record? And why does it matter more than the spooky audio clip going viral? Let's break this illusion apart. Sound is just vibration traveling through a medium, like air or water. No medium, no sound. And space? It's nearly a perfect vacuum. So if you were floating next to a black hole, you wouldn't hear a roar, a scream, or anything at all. So how do we get sound? In 2022, NASA released a sonification of data from the Perseus galaxy cluster. At its center lies a supermassive black hole, one of the most powerful known. This black hole is actively feeding on surrounding matter and blasting energy into the hot gas around it. That gas, yes, gas, creates pressure waves. And unlike empty space, this galaxy cluster is filled with extremely hot plasma. That plasma acts as a medium. Back in 2003, NASA's Chandra X-ray Observatory detected ripples in this hot gas. These ripples were pressure waves, basically sound waves generated by the black hole's activity. Scientists calculated their frequency. And here's where it gets wild. The sound was a B-flat, but not the B-flat you hear on a piano. This note is about 57 octaves below middle C. That's so low that no human ear could ever detect it. Its frequency is about one cycle every 10 million years. Let that sink in. One vibration every 10 million years. Pattern interrupt. Imagine pressing a piano key and waiting 10 million years for the next vibration. That's the scale we're talking about. NASA didn't record this sound like a microphone in space. Instead, they converted the X-ray data into audio by scaling the frequencies up by about 144 quadrillion times to bring it into the human hearing range. That eerie moan you hear online, it's real data, just translated into something our ears can process. And here's why that matters. This isn't just a cool space soundtrack. It's evidence of how black holes regulate galaxies. Controversial statement. Black holes don't just destroy. They create balance. For decades, black holes were portrayed as cosmic vacuum cleaners, objects that mindlessly devour everything nearby. But observations from Chandra, the Event Horizon Telescope, and other missions have revealed something more complex. Supermassive black holes at the centers of galaxies can control star formation. Here's how. When matter falls toward a black hole, it doesn't just disappear instantly. It forms an accretion disk, heats up to millions of degrees, and emits powerful radiation. Some of that energy gets channeled into enormous jets that blast outward at near light speed. In galaxy clusters like Perseus, this energy inflates gigantic bubbles in the surrounding hot gas. Those bubbles create pressure waves, the sound we're talking about. These waves prevent the gas from cooling too quickly. And if gas cools too fast, it collapses and forms stars at extreme rates. By reheating the gas, the black hole prevents runaway star formation. In other words, it stops the galaxy from burning through its fuel too quickly. Without that feedback mechanism, galaxies would look very different. So that haunting tone from Perseus? It's the sound of a galaxy being regulated. Now let's zoom out. The Perseus cluster is about 250 million light years away and is one of the most massive known objects in the universe. The central black hole is billions of times the mass of our sun. The pressure waves detected extend over hundreds of thousands of light years. And here's another twist. This isn't unique. Astronomers have found similar feedback effects in many galaxy clusters. The idea that black holes shape galaxy evolution is now a central pillar of astrophysics. In fact, current cosmological simulations, like the Illustrious and Eagle projects, require black hole feedback to accurately reproduce the universe we observe. Without including black hole energy output, simulated galaxies grow too big and form too many stars. Reality doesn't match unless black holes are part of the equation. Let's pause here. For years, black holes were framed as the villains of the cosmos. But modern evidence suggests they're more like cosmic thermostats. That's a massive shift in perspective. And it gets deeper. In 2015, scientists detected gravitational waves for the first time, ripples in space-time caused by merging black holes. That discovery confirmed a major prediction of Einstein's general relativity. In 2019, we saw the first direct image of a black hole shadow in galaxy M87. In 2022, we saw the image of Sagittarius A*, the black hole at the center of our own Milky Way. Each discovery has peeled back another layer of mystery. But this sound from Perseus hits differently because it translates abstract astrophysics into something emotional. You don't just read about pressure waves. You hear them, and humans connect to sound instinctively. Here's the pattern interrupt again. The universe isn't silent. It's just playing a frequency we weren't built to hear. Through sonification, turning data into sound, scientists are finding new ways to explore complex information. It's not just artistic. It can reveal patterns that visual analysis might miss. Sonification is now used in studying pulsars, exoplanets, and even solar activity. But let's clear up one misconception. If you fell into a black hole, you wouldn't hear this sound building up around you. You wouldn't hear anything. Near the event horizon, tidal forces would stretch you in a process called spaghettification, assuming the black hole is small enough. For supermassive black holes, you might cross the event horizon without immediately noticing anything unusual locally. But sound? Still no. There's no air to carry it. So the viral black hole sound isn't what you'd hear in space. It's the translated rhythm of energy interacting with matter on a colossal scale. And that's arguably more fascinating, because it tells us that black holes are not just endpoints. They are engines. They're architects. They're dynamic participants in cosmic evolution. Think about this. The same type of object that can trap light itself is also responsible for preventing galaxies from overheating with star birth. That's not destruction. That's regulation. The universe is not chaos. It's structured chaos. And we're only beginning to tune in. Right now, next-generation observatories like the James Webb Space Telescope and the upcoming Athena X-ray Observatory are poised to refine our understanding of black hole feedback even further. We're mapping how energy flows through galaxy clusters. We're measuring how black holes grow over cosmic time. We're listening, not with ears, but with instruments sensitive to X-rays, gravitational waves, and radio emissions. Every dataset is another hidden soundtrack. So the next time you hear that deep, haunting tone labeled the sound of a black hole, remember this. You're not listening to a monster. You're listening to pressure waves in superheated plasma, generated by a supermassive black hole shaping the fate of an entire galaxy cluster 250 million years ago. That vibration began before dinosaurs walked the Earth. And somehow, through physics, mathematics, and human curiosity, it reached your speakers. If that doesn't change how you see the universe, what will? If you want more mind-bending but scientifically accurate journeys into space, where we separate viral myths from real cosmic truth, make sure you follow this channel so you don't miss the next discovery. Now I want to hear from you. If black holes can regulate galaxies instead of just destroying them, what other cosmic villains do you think we've misunderstood?